All right, so now we'll do learning target number 4. Now, as we read this learning target, I can solve one-step inequalities using inverse operations. Now, if you'll think back, if you remember, which hopefully you do, in learning target number 1, does anybody remember what it said? It said I can solve one-step what? Equations, right? Do you guys understand that? I can solve one-step equations. Now, I don't want you to cross off inequalities. Sorry. I'm just showing you that I'm proving something. Learning target number 1 and number 4 are the exact same thing, except we're not doing equations anymore. We're doing inequalities. But why I tell you that is because the process is exactly the same. So if you know how to solve equations, then guess what? You can solve inequalities very easily. Okay? So, here we go. Now, I didn't leave you very much room. I apologize. You'll have to come over here and kind of rewrite the problem, because there's not going to be enough room to solve. So everybody's going to have to do this. So you can see the difference here, guys. What's the only difference between this and an inequality? Or an equation, I'm sorry. What's the only difference between this and an equation? Yes? The equal sign. This would say this. And then ask yourself, you would draw a line, right? So what do you got to do here? Draw a line. Nothing changes. Nothing changes at all. It's still the same exact process. Okay. Now we ask what? Crystal, do you remember? What is happening to the variable? So now I ask you that. What is happening to the variable? 8 is being added to it. So how do I undo adding 8? I'm going to subtract 8. Do I need to do it from both sides? Absolutely. What am I left with on the left side of the line? Just x. Now, can I put an equal sign in here? No, because this is an inequality. Because the reason that stayed equals down here is because that was an equal sign. Don't I just need to bring down my greater than or equal to? So what is 18 minus 8? 10. Now we take it and we graph it. So, is that going to be a closed or an open dot on 10? Now, are we wanting to know, are all the solutions for x those that are bigger than 10 or less than 10? Bigger, so we're going to shade to the right. Everybody see how we did that? Same exact thing. It's very basic. Please don't work ahead of me, though. Always want to take a number and plug it in. I'm just going to grab 12 and plug it in. Is 12 greater than or equal to 10? Yes, it is. Is that easy or what? Easy, right? Let's do the next one. You have to go over to the right if there's room and rewrite the problem. X minus 1 is greater than 6. Okay? So, do I need to draw a line? And then we ask, Sam, what is happening to the variable? And then I ask you that. What is happening to the variable? Ashley? What is being? X is being subtracted by 1. I always like to say it the other way and just say it as 1 is being taken from x. How can I undo that then, Danielle? Add 1. Add 1. So then we bring down x over here. Does my inequality symbol stay the same?
Yes.
Absolutely. And 6 plus 1 is? 7. So there you go. There's my problem. So I need to find 7. Here it is. Is this going to be an open or a closed dot, Caitlin? It's going to be an open dot over 7. Now, are the solutions for x, are those going to be ones that are to the right of that dot, of that 7, or to the left, Ben? To the right. Okay. And again, let me just show you this real quick. It is to the right, but let's say you accidentally did left. I get it. Sometimes you make silly mistakes. We all do it. But that's why the plug-in method has got to be something you've got to do. Because if you're saying everything to the left makes this true, and you pick something, and then you do this, is that true, guys? Is 6 greater than 7? Never. Okay, so that's why it's so important to check. Okay, you got to check it. And only about half of you will. But you should be checking. So I'll just pick 12 since it's there. 12 greater than 7. Is that true, guys? Yes, it is. Okay. On this one, same way, we'll have to rewrite it. N minus 2 is less than or equal to 4. draw our line. We ask what is happening to the variable, and we know that the variable is being subtracted by 2, or 2 is being taken from it. So we're going to add 2. Right, guys? It's going to leave us with n is less than or equal to 6. Right, guys? Is that going to be a closed or an open dot over 6? It's going to be a closed dot. Now, is the answers for n here, the possible numbers that I could plug into n, are those going to be found to the right of 6 or to the left of 6, Abdul? To the left. Then what do we do finally, just to make sure? Just pick a number. So I'm going to grab 4. Is 4 less than or equal to 6, guys?
Yeah.
And I'm just taking something I'm plugging in for n. Okay? Next one. V minus 1 is less than 3. Draw our line. We know that the variable is 1 is being taken from the variable. So I'm going to undo that by adding 1. Right, guys? I'm left with V less than 4. Everybody see that? Is that going to be a closed or an open dot? Oh, it's going to be an open dot over the number 4. Now, where are the possible answers for V? Are they to the left of 4 or are they to the right of 4? Yes. They are to the left. And then what's that last step we should always take? Just pick a number. What number you want to use, guys?
2.
We'll use 2. Okay, we put 2 in there. Guys, is that a true statement? Is 2 less than 4, guys? Yes, it is. Okay, here, make sure. By the way, you see that the variable's on the right. You can do this one of 2 ways. You can leave it like that, or can you just go ahead and make it p plus 16 is less than or equal to 20? And just write it that way you're used to seeing it? Sure, you don't have to. I'll show you the other way. Okay, I'm going to leave it like that for now, because I'll show you how to flip it at the end. So we draw a line. We know that the variable 16 is being added to the variable, so I'm going to subtract 16. And I'm going to be left with p on the right. I'm going to leave my inequality exactly the same, and I'm going to get 4. Now let's say you're somebody that doesn't like this way, which is totally fine with me. Can I just flip it now at the end real quick? So what's it going to read? Is it going to be less than or equal to 4, guys? Because it's trying to eat the 4. It's saying that the number 4 has to be greater than or equal to p. So that means, if you think about it the opposite way, p must be less than or equal to 4. So I just rewrote it. Is that going to be a closed or an open dot, guys? Closed dot. Now, are we talking about solutions that would make this true? Would they be to the left or to the right of 4, Crystal? To the left. Now we're going to take a number and plug it in. I'll just grab 1 here since it's in there. Is 1 less than or equal to 4? Hello?
Yes.
And you guys do understand that it isn't just 1. I could take 2, I could take 3, I could take 0, I could take anything negative. I could take any decimal between 3 and 4, 2 and 3, 1 and 2. I could pick anything. This is the only way that you can represent that all numbers, every number less than or equal to 4 is a solution to that inequality. Right, guys? And if you want, I mean, you can take it and plug it into your original one too. So let's say you take 1 and plug 1 in there. Okay, that's 17, right? Is 20 greater than or equal to 17? Hello? Yes, it is. Okay, same way here. We got 11 greater than or equal to 8 plus n. Draw our line. I'm going to be subtracting 8 from both sides. I know that's going to leave me with 3 greater than or equal to n. Can I go ahead and flip it now? I make sure I got to flip my sign. It's going to be less than or equal to 3. Okay? Is that going to be a closed or an open dot? Are you ready for this? Come on. Closed or open, guys? Closed dot. Now, where are my solutions to that inequality? Are they going to be to the left of 3 or to the right of 3?
Left.
They're going to absolutely be to the left. Pick a number. Plug in 0. Is 0 less than or equal to 3? So there we go. We checked to make sure. Okay. Shh. Okay. Here we go. I'm going to skip the top 2 up. Actually, I do want to do this one. 23. Okay, let's talk about this one. This one's weird because this is weird thinking about adding negative if you're thinking backwards, right? But here's where it comes back to this. Remember that thing I showed you the other day? That 2 minus 3 could actually be written as negative 3 plus 2. You guys remember that? That's the integer negative 3 going there, and the integer positive 2 going there. You guys remember that? So could you take this and make this 8 minus 11? It's the same thing, right? That's the integer positive a. That's the integer negative 11. Okay, that's weird to think about. But basically what you're going to do here is you'd be, let me rewrite it so you can see it, 6 greater than negative 11 plus a. So that means I'm going to do what? Add 11, right? That's weird to think about, I know. And add 11. Forgot my line, didn't I? Okay, I know that a is going to look like this. And I'm going to rewrite it as a less than 17. So here we go. I'm going to have an open dot over 17. Where are my solutions this time, Ashley?
It's going to be to the left.
Now I plug in a solution, guys. Is 15 less than 17? Yes, it is. We're going to skip that one. Okay, let's go to these ones. Multiply and divide. Nothing changes, guys. What is happening to the variable? Hello, anybody? It's being divided by 5. How do I undo dividing by 5? Multiply by 5. Multiply by 5. It's going to give me n less than or equal to 10. Open or closed, guys?
Closed.
Closed dot. Now, are my solutions going to be the right or the left, Ohm? So you're saying that all of the solutions that would make this true are to the right? No, because we're talking about values, solutions, that are less than or equal to 10, which means we're going to go to the left. Now we're going to pick a number. Pick 7. Is 7 less than or equal to 10, guys? Okay. Here we go. I got 14v less than or equal to 14. Okay, what is happening to the variable in this case? It's being multiplied by 14. So how do I undo multiplying by 14, Eddie? Divided by 14. Divided by 14. I'm going to be left with v less than or equal to 1. Any number divided by itself is 1. So is this going to be an open or a closed dot, Ben?
It would be a closed because
It's the or equal to. That's the part that makes it a closed dot. Okay, because it includes 1. 1 makes it also true. Now, where are the values less than or equal to 1, Natalie? You got it. Can I plug in 0 just to check? Well, they just have worked out that way. Is 0 less than or equal to 1? Yep. Okay, this one, we got n divided by 2 less than 0. Okay. What is happening to the variable? Jessica? So I need to undo that by multiplying by 2. Okay, and that's going to give me n less than 0, right guys? Okay. So that means I'm going to put an open dot over 0. And are we talking about values that are to the left of 0 or to the right, Crystal? To the left. You got it. Plug in a number, guys. Is negative 3 less than 0? Absolutely. Last one here. We got 8 greater than 8n. By the way, if you wanted, right at the beginning, you could just make this right away. I'd be fine with that. Putting the variable term on the left. But just remember, you got to flip the inequality sign as well. But I'm going to leave it without it for now. I know that the variable is being multiplied by 8, so I'm going to divide by 8. And divide by 8. Then I'm going to get this. Now I'm going to flip it because I just like to look at it with the variable on the left. Right? Now is this going to be an open or a closed dot, everybody?
Open.
Open. Now, where are my solutions? Are they less than 1 or are they greater than 1? Less than 1 once again. Pick a number. I'll take 0. Is 0 less than 1?
Yes.
Could I pick any number, by the way, that's in that shaded region?
Yes.
Absolutely.